This video is about how to solve a system of equations algebraically using substitution. Let's get started. This right here is a system of equations, meaning I have two or more equations that are related so that the x in the first equation is the same x as the x in the second equation, and the same is true for y. So these two equations are connected because they have the exact same variables happening at the same time. So a frequent question we want to know is, when are these two equations true at the same time? Okay, that's an important question for us. So this video explains how to answer this using substitution, which is probably the method that will work most often for solving them algebraically when you don't have two linear equations. Okay. Now, our first step is to solve for the simplest variable. Okay, so looking at this, I have variables, let me change colors here. I have variables here, and here, and here, and here. Now this x squared is definitely not the easiest because this x is being squared. So to solve for that variable, I would end up with some square roots, and it would not be the simplest. Okay. Now, of these other three linear terms, this one right here has a coefficient of -1. Okay. So that might be the easiest one to solve for. So I'm not dividing by 2 or 3 and getting more fractions to deal with. Okay. So I will solve this bottom equation for y. Okay, and in truth, it doesn't really matter what you solve for, but to make it as easy as possible, we will solve for the simplest variable. To do that, I will add y to both sides, and I get 3x, this cancels, equals 9 plus y, and then I will subtract 9 from both sides, and I get 3x minus 9 is equal to y, which is exactly what we have here. Okay, but that's how we did it and why we did it. Okay, so you first solve for the simplest variable. The second step is where you plug what that variable is equal to, and you plug it into the other equation. Okay, so I can't plug it back into the same equation. That won't really help me to solve it. I will plug it into the other equation. I probably should have drawn it like this instead, into that y right there, which looks like this. So in place of this y, I will put in parentheses this 3x minus 9. Okay, and now I have an equation with only one variable. Now sometimes it's y, but this time it's x. I have an equation in terms of x. And so I will solve that. Let me just actually erase this and scroll up. So I will distribute this 2 into both the 3x and the minus 9. And so I get 6x minus 18 there. Okay. And then I will combine like terms. -18 plus 10 is -8. Okay. Now this is a quadratic equation. I have x squared and x, and what we typically do is you get one side equal to 0 so that I can eventually use the zero product property. Now, I like my leading coefficients to be positive, and so what I'm actually going to do is I'm going to move, or I'm going to subtract 6x from both sides and add 8 to both sides. Okay, and then to put that into standard form, I get x squared minus 6x plus 8 equals 0. Okay, now is this factorable? I know that you can see it on the board, but I'm thinking through how I would do this if I didn't know it was coming up. It's a trinomial where the leading coefficient is 1. That's a simple ABC method. I'm looking for factors of 8. That add up to be -6. Well, It's a positive 8, so both numbers are either both positive or both negative. In this case, they add to be negative 6. They must both be negative. I think it's negative 2 and negative 4. Okay, so I factor this into this binomial. Okay, and then I use the zero product property and put each factor equal to 0 and solve. Okay, so this step, step 3, is to solve that equation. Okay, be aware that when we're solving nonlinear systems of equations, you could have 1, you could have 2, you could have 3 or 4 or multiple solutions. Okay, so don't be surprised when you come up with your answer at being more than 1. In fact, I think frequently 2 is a common number of solutions that we get in these problems. Okay, so in this case, when I solve that, I get 2 solutions. Okay, that shouldn't surprise you. But again, don't forget that we're solving a system of equations, meaning I have, in this case, 2 equations with 2 unknowns, both x and y. So the last step is to plug those x values into one of the original equations to find the y value. So we'll plug these solutions, x equals 4 and x equals 2, into the equation that we found in step 1. Okay, now in this case, it was y is equal to 3x minus 9 was the solution we found in step 1. Okay, that's almost always the easiest ones to plug back into. It's already solved for what you're looking for. Okay, so if I do that here, if x is 4, looking at this one, then I get y is equal to 3 times 4 minus 9, and so I get 12 minus 9, which is 3. Okay, and then you write it as an ordered pair. Okay, and so if x is 2, let me switch colors. If x is 2, from here I plug again into x right here and get 3 times 2 minus 9, which is 6 minus 9, which is negative 3, and I write it down as an ordered pair. All right, that's the process. I know it feels long, but what we're basically doing is solving the one equation for one variable, plugging it into the other, solving that, and then plugging it back, so a back substitution to find the other variable. Let's look at one more where it's not like step-by-step guided out to us. So I'm going to call this example 2. We are given the system right here. Okay, and my first step is to solve for one of the variables. I look for the easiest variable. Okay, it is not this one or this one because it's in a parentheses and being squared, and that would be really messy. So I'm looking at this other equation here that looks simpler. Okay, and this x right here looks to be the simplest thing to solve for. So I will start off with that equation, x plus 2y equals 0, and I will subtract 2y from both sides, and I get x is equal to negative 2y. That's the first step. Now the second step is where I plug this into the x's in the other equation. Okay, so I will do that, and so I get parenthesis negative 2y minus 1 squared plus y minus 1 squared equals 5. Now the next thing that we'll do is that I will think through what it means to square something. Okay, to square something means multiply it by itself. So I will square both of these binomials by writing it as negative 2y minus 1 and negative 2y minus 1. And to square y minus 1, I get y minus 1 times y minus 1 equals 5. So then I'm just expanding these. Negative 2y times negative 2y is a positive y squared. Negative 2y times negative 1, a negative times a negative is a positive 2y. And negative 1 times negative 2y, a negative times a negative is a positive 2y. And then negative 1 times negative 1 is a positive 1 plus. Okay, y times y is y squared. Y times -1 is -y. -1 times y is -y. -1 times -1 is +1 equals 5. Okay, so now I'm just like solving this equation, and the next step might be to combine like terms. So let's combine like terms. I have 4 y squareds and 1 more y squared, so I have 5 y squares. I have 2 y's and 2 more y's, that's 4 y's. But then I subtract 1, so I have 3 y's left, and then take away 1 more, and I have 2 y's left. So plus 2y, and then 1 plus 1 equals 2 equals 5. Okay. Now, this is a quadratic in terms of y, and I want to get one side equal to 0. And I will do that by subtracting 5 from both sides, and I get, I'm actually going to put it up here just so I have some more space. I get 5y squared plus 2y minus 3 equals 0. So I want to factor this if I can. And let's see here. This is the more complicated ABC method because my leading coefficient is not equal to 1. So I multiply A times C and get 5 times -3, which is -15. And I'm looking for factors of -15 that add to be 2. Well, if it's -15, I need a positive and a negative, and the bigger one is positive because this number is positive. So I'm thinking that through, and I think it's going to be +5 and -3 is the pair that I want, because those multiply to be -15, and they add to be +2. So I'll break up this 2y into 5y squared plus 5y minus 3y minus 3 equals 0. And now I will do factor by grouping. So in these first two terms, my GCF is 5y, and I'm left with y plus 1. And in these last two terms, now this term right here is negative, so I'll pull out a -3, and I'm left with y plus 1 equals 0. Now I'm really happy that I get y plus 1 and y plus 1. I think I'm on the right track. I'll pull out the y plus 1 in front, y plus 1. I'm left with 5y minus 3 equals 0. And then I use the zero product property and put each of them equal to 0. So what number plus 1 is 0? That's y is equal to -1. Okay, this is a little more complicated. I have 5y minus 3 equals 0. I will add 3 to both sides, and I get 5y is equal to 3. Divide by 5, divide by 5, and y is equal to 3/5. Now, I know you're feeling like you're done, but I've only found the y values at these intersection points, or where both equations are true at the same time. I need to find the corresponding x values. Okay, so I go back to the equation I used in step 1 and plug things back in there. So here is x equals -2y, but I'm going to plug in -1 in for y. And so x equals -2 times -1, and I get x equals +2, because a negative times a negative is a positive. Now, writing that as an ordered pair, it is x and then y. This ordered pair is one of my solutions for where these two equations are true at the same time. The other one comes from the y is equal to 3/5. Again, x is equal to -2y. I plug 3/5 in for y, and I get x is equal to -2 times 3/5. I multiply fractions by multiplying the tops and the bottoms together. And so I get x is equal to -2 times 3 is 6. 1 times 5 is 5. And I'm kind of out of room. I'm going to put it over here in this little space right here. So the x coordinate is -6/5, and the y coordinate is 3/5. So this is my other solution. I know the page is super busy right now, so let me kind of just highlight this. These are the two solutions, the two places, or I guess you say x and y values, that make both equations true at the same time. Again, the process is you solve for the simplest variable, plug that into the other equation, you solve, and then back substitute to find the other variable. All right, this video was about solving a system of equations algebraically using substitution. Thank you for watching.